This conference will now be recorded.
Good morning, friends. In this Business Intelligence Master Program, so in this session, we are going to see copy data from Azure SQLDB to CosmosDB, and we are also going to see how you can copy data from blob storage to the CosmosDB. Okay, so we are going to do total 4 labs. One is copying data from SQLDB to CosmosDB, vice versa, meaning CosmosDB to SQLDB in reverse way, how you can do. In the same way, copy data from blob storage to CosmosDB, CosmosDB to blob storage. Okay, those are the 4 labs we are going to see. Let's see. In today's session, we will see scenarios and what is CosmosDB, difference between SQL and NoSQL, because CosmosDB is a NoSQL database. Okay, so we will see the difference between SQL and NoSQL, how the data will store in NoSQL. We will see. If it is a SQL, we know already data will be stored it in a tables. So we know already how you can query on the table to fetch the data, how you can filter out the data which is there in a tables, all those things. Next, estimations, prerequisite and required resources. These things you know anyhow. Demo, we will see how to create SQL database, how to create blob storage, how to create CosmosDB. So this is the one which is new today. Okay, remaining things we already created. Next, create Azure Data Factory V2. Then create linked service for blob with keywords using integration runtime. Create linked service for Azure SQLDB with the keywords using integration runtime. Okay, we are going to create the linked service for blob, Azure SQLDB, and linked service for CosmosDB. Then we will see create multiple data sets, create pipeline. We will debug the pipeline and we can run the pipeline. Finally, we are going to monitor this pipeline. So before I go and start scenarios, what I wanted to do, I want to create all the resources that I need. So I hope you understood what are resources I need. I need to create SQLDB, blob storage, CosmosDB, Azure Data Factory V2, and keywords, because I want to use keywords. Let's go and create all these things. Why I want to create all these things earlier? Because CosmosDB will take at least 14 to 15 minutes. Okay, so I don't want to waste that much time. Let's say if I create resources now, by the time we complete slides, resources will be available. Okay, so let me just go to fine. I am here. Let's create a one by one. Let's create CosmosDB first, Azure CosmosDB. So this is the one which I want to create. So here also you can see, you can search here also, you'll get CosmosDB. Okay, so Azure CosmosDB, just click on that, you will come here. Once you are here, just click add to create the Azure CosmosDB. Okay, so let's create a resource group. Click create new, Cloud Pandit BI Master Program. Okay, so BI Master Program, click OK. Now account name is, it's basically you can say Cloud Pandit Cosmos account. Okay. Cloud Pandit Cosmos account. So we have a different ways to work with Cosmos DB. One is SQL API, okay, MongoDB API, Cassandra, Azure Tables, Gremlin. This is basically graph objects. We'll have a graphs, okay. But basically we know SQL, right? So I want to query it on this whatever data I have in Cosmos, I want to query it by using SQL syntax and all those things. Then you need to use the SQL API. So we all familiar with SQL. So let's go with SQL API. And even Azure Data Factory will support only SQL and MongoDB API. Okay, if you are using Cassandra, Azure Table, okay, Graph, then you need to go with Azure Databricks. You cannot read data by using Cassandra, Azure Table, Gremlin, by using Azure Data Factory. You need to use Databricks for that. But if you are going to use Azure Data Factory to do some kind of a copying, or if you want to load some data into Azure Cosmos DB and all those things, you need to go with SQL or MongoDB API. These two only will support. So let's go with SQL because we are a little bit familiar. Next, notebook. So you can create the notebooks and you can write Spark code here itself. Okay, so that is still in preview. Preview means you should not use this particular option for the production, because this is not sure. They are going to include this particular option. Based on the customer's feedback, they will decide whether to keep this notebook option in this Cosmos DB or not. Okay, next. So in which region you want to launch this particular Cosmos DB account, in West US or whatever you want to select, you can select. Okay, let it be default West US. Next, capacity mode, provisioned throughput serverless. Serverless means serverless still in preview, but you know, right? Serverless means we no need to worry about the compute power. Okay, how many servers we need, what is the size, how much memory we need, how many cores we need, all those things we no need to worry. You just submit job. Based on the job, how much is required, that much resources will be assigned to that particular job if you go with serverless. Okay, if you go with provision, see, when I go with serverless, there is no other option. But if I go with provisioned throughput, it is saying Cosmos DB free tier, you will get 400 RU read units per second. Okay, so these are the compute power that you are taking. So if you want to increase 800 read units per second something, you can take it. So one read unit can read 4 KB of data per second. Now if you have 400 RUs means 1600 KB you can able to read at a time. You know, right? Size, kilobytes, megabytes, gigabytes, right? So we will use KB, MB, GB, right? So one RU can read 4 KB of data. So now you are using 400 RUs means 400 into 4, 1600 KB it can able to read per second. If you want to increase this compute power, you can increase. But serverless means you won't get all those options. See, everything will be taken care by Microsoft. Now provision throughput. Account type, do you, are you, see, next, apply free tier discount. Yes, I want to apply. Account type, production or non-production. This is basically for non-production. Geo redundancy means we already discussed. Redundancy means replication factor, right? So where you want to keep another copies of your data. Okay, that is the geo redundancy. If you enable, so what happens is data will be written to the multiple geographical, so that even if you lose one copy, you'll have another copy. For now, I am disabling. Next, multi-regional writes. Let's say when you are writing data into India data center, simultaneously, if you want to make sure same data available in US data center, what happens? You are going to, let's say I am uploading one video in YouTube. This video I will just enable multi-regional rights. What happens? This video will be available not only India data center, this video will be available in US data center, UK data center, and the multiple data center, whatever you select. You are going to once you enable, you are going to select. After this account is created, you can able to select it. I will show you once again. But when I upload video in YouTube, what happens? That will be there in a India data center. But when you enable multi-regional rights, same video will be available in multiple regions, means same video will be written to the multiple data centers. Now, what is the advantage of writing to different data centers? The advantage is, if you have data near to you, it will be much more easy and fast for accessing. Okay, so example, somebody is there in the US, he is trying to access the data which is there in India, it will take more time for him. But the same person is accessing from India, data is also in India, it will take less time, right? So that's why what we need to do, same video, we make sure that we are keeping near to the customers. When we keep same content near to the customer, customers can able to access data quickly. Okay, so that is the meaning. I will just show you. After creating account, you can clearly see in what all data centers we have, where and all you want to write at a time, how you want to write. There are different options. We will see all those things. Next, networking, backup policies, all those things we don't require, just leave it. Click review plus create. See what it is saying, estimated account creation time in minutes, 15 minutes. You understood? That's why I'm just starting with Azure Cosmos DB, let it create. Next, what else we need to create? Azure SQL database. Let's create Azure SQL database as well. Let's click on SQL databases. Click add to create the SQL databases. So I'll just select the resource group which I have selected. Let's create a cloud funded SQL DB. Create new. This is going to be cloud funded SQL server. You know all these things, so I'm just providing all those details quickly. Okay, click OK. Then you know all these things. Click review plus create. I'm just purchasing what mode? Database transaction units. So based on DTOs, I'm purchasing database. That's okay. Let's create now storage account, blob storage. Click on storage account. Click add to create the storage account. Okay. Cloud Pandit BA master program. So storage account name, I will just say Cloud Pandit blob storage. Cloud Pandit blob storage. Click review plus create. Click create. Now come here. So I will just create here Azure Data Factory. Click on it. Click add to create the data factory. This is the resource group. Is to S name. So name I will just say Cloud Pandit BI of P2 Cloud 30. Git configuration. Git configure later. Click review plus create. Click create. Okay. Next. Finally, what we need to create the Azure keyword. Let's create Azure keyword as well. Click on keywords. Click add to create the keywords. Create right, and resource group is this one. This is Azure keyword name. Keywords. Azure keyword 1230. So access policies. Let's add our data factory here. Let me just give the full access. Select a principal. Here I'll just give the data factory name. Edit. Click review plus create. So almost we have created everything. Okay, let's see. SQL database is deploying. CosmosDB is deployed. Storage account already created. Data factory is also created. Now keyword is going to create. Okay, let's go back to our slides. Okay, these are the things. Scenarios. So what all things we will cover today? We will see how to copy. Okay, copy data from blob to Azure Cosmos DB. Copy data from SQL DB to Cosmos DB. Then vice versa. Copy data from Azure Cosmos DB to blob. Okay, Azure Cosmos DB to SQL DB. So what activity we will use today? We will use copy activity. Okay, this is clear, right? Next, overview diagram you see. So how I will connect to the Azure Cosmos DB is we have a data source. Let's say whether you have data in Cosmos DB or you want to load data into Cosmos DB. So our data source is CosmosDB. So CosmosDB, like the keys, I will keep it in a keyword. Okay. Then I want to connect to the CosmosDB from ADF. First, I will go to keywords. I will read the credentials. With the help of those credentials, I will connect to the CosmosDB. Okay, I will connect to the CosmosDB. Once I connected to the CosmosDB, I can able to read and write. I can able to read and write the data into the data factory. From CosmosDB, I can able to read into the Azure Data Factory. Azure Data Factory will load data into different sources, or Azure Data Factory will bring data from different sources and load it into CosmosDB. Okay. Next. So Azure CosmosDB. What is this Azure CosmosDB all about? Okay. See, today's applications are required to be highly responsive and always online. Why highly responsive? Let's say you are trying to purchase, say, one item in Flipkart. You are trying to access Flipkart website. If it is not available, do you think are you going to wait up to the application is up? No, you will simply go to other website and you will just check out some item, right? So meaning, if the application is not online, what happens? You are going to lose a business. Second thing, you are trying to access some application, or you are trying to place a order in Flipkart. It is taking a lot of time. Then what you will do? Just you will get some work, you will ignore that there, and next time you may try with other websites. Okay, maybe Amazon or Snapdeal or somewhere else you will try, right? So meaning, why this is happened? Again, business loss. The reason is it's not highly responsive. This is not online. If these two cases happen, you are going to lose the business. That's why what we need today, applications are required to be highly responsive and always online. Highly responsive means when somebody accessed, it should respond very quickly. Okay, then it should be available always online. If it is available, then only it will give the response. But can you tell me, if just guess it and tell me, friends, if I want to access data quickly, where I should keep data, in India or US? Data should be near to me, or data can be there far away from me?
Near to us.
Near to us. Remember, data should be there near to us. Okay, that is important point. You see, to achieve low latency and high availability, low latency means the access time, the time which takes to give the response, it should be very low. That's why to achieve low latency, okay, and high available, it should be always available. Instance of these applications, okay, these kind of applications need to deploy in data centers that are close to their users. Okay, we need to deploy these applications near to users. If you have more users in India, then you just deploy your application in India. You have more users in US, just deploy another instance, same copy of application in US as well. Don't use same application which are deployed in India, because it will take more time to respond for the users who are accessing from US. Understood? Next, applications need to respond in real time to large changes in usage at peak hours. Okay, let's say sometimes what happens, if you look at online, this train ticket booking, I hope many of you tried, right? At 10 o'clock AC tickets. Okay, this is like little bit peak hours. At 11 o'clock sleeper class, right? So what happens is many people will try to access it. Many people will try to access it, but only few people will get the tickets whoever internet is good. Okay, whoever mobile or whatever is not stuck, or whoever application is working fine, right? So all these things will be a matter. So that's why what kind of application we need is the application which should respond to the large changes in a usage at a peak hours. So many people are going to access your application, but still your application should be able to respond immediately, even though you have lot of traffic, lot of traffic and lot of pressure on the server should be able to respond. How? So you need to take care of all those things, right? Next, store ever increasing volume of data, make this data available to users in milliseconds. Let's say cricket. Okay, when cricket match is happening, what happens is So people in QuickBuzz, people will keep on refreshing. Why? They want to see immediately. They want to see response immediately, right? So maybe lot of data changes will happen. Maybe let's say batsman score unit increase, bowler like ball count unit increase, total score unit increase. So if batsman achieved some highest score or something, you need to make. So all these changes will reflect within a seconds, milliseconds. This data is available to all the users. How this data is available to all users? Okay, they are using some applications, meaning, but we need to understand the requirement. The requirement here is you should be able to handle large changes at peak hours. Second thing is, we don't know how much data we are going to get. Whatever data comes, that data we should be able to store. That is second one. Third thing, whatever data I am storing, unlimited data, that data immediately users can able to access it. These are the 3 points you should understand. Okay, so why I am explaining all these points, because these 3 are the very important for the business, but these 3 you can able to achieve it by using CosmosDB. Okay, Azure CosmosDB is a fully managed NoSQL database for modern app development. Okay, the kind of like whatever requirement you have, all these requirements you can able to fulfill by using CosmosDB. Okay, it is fully managed NoSQL database, meaning who is going to manage this particular database? Microsoft is going to take care of everything. You no need to worry. Okay, so replicating data into different data centers and large changes, responding to the large changes, and the data available to other users immediately, all these things taken care by the Microsoft. Okay, so if you have such kind of requirement, you need to use the CosmosDB. Okay, mainly CosmosDB is used for the mobile applications, because nowadays, you know, right, so everybody is using mobiles. In mobile, they want to see immediate updates, right? So what people will do, so something happen, immediately they will browse. Okay, I heard something, so whether it is true or false, immediately they will search in the Google, right? So then they should get the response. How they will get the response immediately? How they will get the response immediately? They need to use the application such as CosmosDB. Okay, see, CosmosDB good thing is single digit millisecond response time. So it will respond very quickly and automatic and instant scalability. You don't worry about, let's say I am going to get large amount of data. Will I be able to store this data in a CosmosDB or not? So yes, you can able to store. You don't worry, because it's a scalable. Automatically, it will scale based on the data which you are storing. Next, guarantee speed at any scale. So you don't worry. So how much data you are accessing doesn't matter. You will get the certain speed. Okay, if you increase the compute, then automatically speed will increase. But now we have another option called serverless. If you go with serverless, so you no need to worry, everything will be taken care by the Microsoft. Business continuity is assured with SLA backed availability and enterprise grade security. You have a full security and SLA backed availability. SLA means service level agreement. So they will tell you CosmosDB will be available 99.99999%. Then Microsoft make sure that this CosmosDB is available always, because nobody will give 100%. That's why they will give 99.99999%. Okay, next. Azure CosmosDB takes database administration off your hands with automatic management, updates, and patching. So in this CosmosDB, you no need to worry about anything. Everything, administration task, everything will be done by your Microsoft. Automatic management, automatic updates, automatic patching, everything will be done. So administration you can turn off. Okay, you don't need to hire a admin for maintaining your CosmosDB. That's why, like now, see, admin jobs and all, it is very less in cloud, right? Because most of the things will be taken care by the cloud providers itself. Next, it also handles capacity management with cost-effective serverless automatic scaling option that responds to application needs to match capacity with demand. So cost-effective serverless. So let's say you are keep on using large compute resources, then ultimately you are going to make a lot of payment. To avoid these kind of things, we have a serverless option now. If you want to use serverless, you can use. So based on the usage, you are going to make the payment. So that's how you can able to still save your cost. Okay, so that is all about your CosmosDB. Now see, in Cosmos, you have a first Cosmos account, CosmosDB account. Okay, in this CosmosDB account, So under that we are going to have a databases. You will have a database account, that is nothing but a Cosmos database account. In this Cosmos DB database account, you will have a databases. You can create as many databases as you want under that. In a databases, yeah, can you tell me, let's say we will go with RDBMS so that it will be easy for you to understand. In a server, can we have multiple databases? In a same server, can we have a multiple databases or not? I have shown you. Yes or no, friend? Is it possible to have a multiple databases under one server?
Yes, Manaya, possible.
Okay. Next, in a databases, how we will store the data? In a tables, right? In a tables, what we will have? We will have a records data, right? Same way, in a database like Cosmos database account, you will have a databases. In these databases, you will have a containers. Instead of tables, you will call it as a containers. Inside these containers, you will have a data. In tables, we will call them as the records. In these containers, records is called a items. Those data points are called a items. Okay, let's go further. Okay, we will discuss. See here, we have a database account. Under that, we have a database. In database, we have a container. In this container, we have a stored procedure, user defined function, triggers, conflicts, merge procedures, items. Okay, you will have a items. Here you need to note down, this is the items, meaning all your data will be there in a will be of type items. Okay, so if the data is there in a table, we will call them as the records, right? In the same way, if the data is available in a container, those is called the items. Now, just this is based on the API, whether it is a collection, table, graph, it will change, but SQL means it's a collection. Okay, now come to here items. In items, what you will have? Document, row, node, edge, all this information. You will not know what it means. Let me just show you something so that you will be able to understand. Now you see, if it is the RDBMS, you will have a tables, you will have a master table, you have a child table, something. You will just give some kind of a relation. Okay, okay, here you will have a foreign key, here you will have some primary key, all those things, you know. Now let's say here data in Cosmos DB will store something like this. We have order ID, key and value, 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 key and value. Okay, so for each record, let's say one Rama Bangalore, for that particular record, one document will be created. Okay, same, this kind of curly brace starts end, that will be one document, right? So one Rama Bangalore, for that one document will be created. To Krishna something Hyderabad, that will be there in another document. Okay, remember, so order ID, order date, first name, all these are the data. Now you see something called underscore RID, underscore self, underscore e tag, underscore attachment, underscore TS. These are the system generated tags. These are automatically will come. What it means, what is underscore RID, what is underscore self, what is underscore e tag? Let me show you. What is underscore RID? First you need to understand, it's a system generated key. It identifies your container uniquely. You'll have a multiple containers. In those containers, if you want to identify one container uniquely, you need to use underscore RID. Okay, so e tag for optimistic concurrency control. So optimistic concurrency control means, so you are parallelly reading the data, or you want to do some kind of observe parallelly, then based on the e tag, it is going to identify this is this will come under. So let's say you have a distributions, right? So in distribution means, based on, let's say all Bangalore people will be there in at one place, all Chennai people will be there at one place, Hyderabad people will be there at one place. So it will be easy for us to update all Bangalore people, some phone number or whatever, right? So that's how e tag will be helpful for us to do some kind of a optimistic concurrency control. Next, TS timestamp. Okay, see, last updated timestamp of the container. Okay, so when this container has updated, let's say it will be not like 2020 iPhone 0101, it will be there something like this. Here you can see timestamp will be there something like this. It will be there in a seconds. Okay, remember. Next self means addressable URI of the container. Okay, so this self indicates address of URL, right? So let's say here you see self means, so this is the address of your container. Okay, address of your container. Okay, this particular address you need to use when you are trying to read these particular items from the Azure Databricks, all those things. Okay, you can use these things. Clear? So don't worry, this is first time for you. RDBMS versus Azure Cosmos DB. The difference you see, RDBMS, it's a fixed schema. Cosmos DB, dynamic schema, meaning in RDBMS, let's say you have a table. In table, you have CID, CNAME, C location. Now, customer wants to provide his phone number. Will you be able to take it in RDBMS or not? I have created a table with 3 columns. Now I want to, customer is ready to provide his phone number. Will I be able to take in RDBMS or not? No, it is not possible because it's a fixed schema. We have created a table with 3 columns. At any time, you can able to store only data of those 3 columns, right? So, but Cosmos DB is a dynamic schema, meaning first customer can provide his name and his location. Second customer may provide his customer ID, name, location, address. Next customer may provide his name, designation, and is a salary. So dynamically schema will change for each record. Okay, next. Here this is called tables. Here we will call it as a collection. Next. Okay, collection, or you can say it as a container. Okay, next. Records are rows. Here we will call it as a records are rows. Here we will call them as a items. In RDBMS, we will have a joins can be used, but Cosmos DB will not support joins. Okay, because here we will have a master and child table relationship. That's why you can able to apply joins and you can able to join those 2 tables. But here it's a dynamic schema, so you cannot join. You cannot apply the joins on the items because there is no guarantee that all the items will have particular key. But here child item and master table and the child table will have some key, common key. But in items, it's not guaranteed, right? That's why joins will not supported here. Fine. Next, copy data from SQLDB to Cosmos DB, as you know. So you'll have a SQL server. In that you'll have a database. In database, I have a table. This data I want to move it into the Cosmos DB. So first create a linked service for your SQL database. Then you just create the input data set. Use copy data activity. Okay, output data set which points to the Cosmos DB container, and then you need to create the linked service for Cosmos DB. When you run it, so in a Cosmos DB container, you will have items. Okay, now who is going to do all these things? Azure integration runtime, because both are in a cloud, so you are going to use Azure integration runtime, and you can use Azure Data Factory. Azure Data Factory is going to manage all these things. This is how the flow of Azure SQL database to Cosmos DB if you want to move any data. But vice versa also same, right? So now if you want to move data from blob to Cosmos DB, the only difference is in blob storage you will have a input, and let's say here you have some JSON file or CSV file, whatever. Now Cosmos DB, in this Cosmos DB I have a EMP container. Now I will create a linked service for blob storage, input data set, copy activity, output data set, output linked service, and then I will run. When I run, all these emp.json files will be there as a items in this EMP container. Azure integration runtime will do, and Azure Data Factory will manage all these things. But as we discussed, not only Azure IR, our self-hosted IR also can able to do this particular task. Next, estimations, we know how many linked services we need. One linked service for Azure SQL database, one linked service for your storage account, one linked service for Cosmos DB. Total 3 linked services. Data sets we need to create. So if you are going to use only copy activity, we need 2 data sets, source data set and the sync data set. How many activities? Only copy activity for SQL database to Cosmos DB, for blob to Cosmos DB, 1 copy activity. Even for reverse also, one copy activity only. One pipeline I will create. What type of IR we need to use to copy data from SQL database to Cosmos DB, or vice versa, and blob to Cosmos DB and vice versa. You can use Azure integration runtime or self-hosted integration runtime, but we recommend Azure integration runtime because this is managed by Microsoft. Everything will be taken care by them. We just have to make a payment for the time that we have used this IR with Azure Data Factory. Next, prerequisite. We should know what is Azure SQL database, blob storage, CosmosDB, what is Azure Data Factory, integration runtime and types, linked service dataset activity, and Python. All these things we are good. Okay, required resources are Azure SQL Server database, blob storage, CosmosDB, Azure Key Vault, and ADF-V2. We already created all these things. Okay, we will just go and implement the pipelines. Okay, fine, that's okay. Yeah, so let's come to the CosmosDB. You see CosmosDB is available. So you know about database, blob storage, all these things, because we were discussing about these things since a long time. So what I wanted to do is now, I want to explain you CosmosDB little bit in detail. Go to resource first. As I mentioned, this is a CosmosDB account. Okay, let's click on Data Explorer. Here you see, you can create a container, you can create a database, but can we create a container without database? No. You see, try to create a new container. See, it is asking to select the database, because inside database will have a container. So you can select a new one, you can create a new database, or you can use the existing one, but you don't have any existing one. So what you can do, you can create a database separately here. Create a database separately. See, when you are creating database, we have not selected serverless, we have selected provision, right? So that's why you need to select the throughput units. How many RUs you want all those things. Provision throughput. Okay. Database name I will say Cloud Pandit DB1. Cloud Pandit DB1. Okay. This is a provisioned throughput. Provision throughput, how many I am taking? 400 to 1 lakh RUs you can able to take, but I have taken 400. These are more than enough. Okay, just click OK. Now I have created the database called Cloud Pandit DB1. Okay. Now let's create the container. Okay, see in this we have you don't have anything because this is just empty database, right? Let's create a container, new container. So now you see you have existing one, you can see drop down. If you want to create a new one on the fly also you can create, but I want to use the existing database, that is it. In this I want to create a kind of a table. This is a container ID I will create. Okay, this is, I can call it as a customer table. In the same way, container ID I'm creating as a. Okay, so this is a container ID. So index, automatic, all these things. Partition. So how you want to partition the data? So let's say based on my customer location. Based on my customer location, I want to partition the data. So what happens? All the people who are from Bangalore, that will be there in a one disk. All the people who are from Hyderabad, their data will be there at one disk. It will be easy for us to fetch the data. Okay, you have something called analytical store, all these things. Okay, this is disabled, you need to enable, so that you can able to work with whatever data you have in CosmosDB. This data you can able to read it from the Azure Synapse, and you can able to apply some kind of analytics. You have a unique key constraint. So if you want to put some kind of unique key constraint, you can able to add that unique key. But I don't want anything, just click OK. Don't worry if you don't know unique key. So this is exactly same like a primary key, but only a few differences. You can have a multiple keys in a table, and unique key will allow some kind of a null values in the data. Okay, all those things. Even if you don't know that, no issue. Okay, click on this particular container, go to item, check do you have anything here. You don't have anything. Okay, you see here you have an account. In that I created the database. In database I created the container. In that container I have items. So do I have any items? No. Okay, I don't have any items. This is the first thing. Okay, at the last I will explain other features of the CosmosDB. Okay, for now let's go to the SQL database. Go to resource. Let's click set server firewall. You know, right? We need to turn on the firewalls. Let's click yes, and I'm just add client IP. This is the client IP I added. Save it. Okay, once this is done, you come back. You just open Azure Data Studio. Okay, so Azure Data Studio I open. Let's wait 1 minute. Okay. Okay, so let's click here to connect to the server. This is copy your server name, paste it here. Say SQL login. Username is my name. Password. Database name. So I don't want to load it. Let's say cloud convey SQLDB. Let's connect. Okay. Now right click on this, click new query. Okay. Again, right click on this, click new query now. Yeah, we are here. Okay, just to select database. Okay, database is selected. So you know you don't have any data. I want to create some table. Okay, create table, cust table, PID, ceiling value. Okay, so I want to insert into cust values are just say 1. Okay, Bangalore 2. You can just say you just say 3 Sai. 4 Srinu. We have Chennai. Okay. Something can say that. Okay. Now you see I'm just going to insert all these records into this table. Six rows affected. Okay, I have 6 rows. Now, so meaning I have a table in this database that is called cust table. This cust table data I want to load it in the CosmosDB cust container. For that, come to data factory, open this data factory, click on author and monitor, and I need to store some keys in my Azure Key Vault. For that, first go to CosmosDB, come down and select keys. You see you have something called primary connection string. Copy and paste that connection string here, and let's verify, do I need to modify anything? No. So this is the exact connection string. I can store it in my keyword. Okay, copy Copy this connection string, come to keyword, go to resource, click on secrets, click generate/import. You can say here CosmosDB connection string CS. Okay, Cosmos connection string, Cosmos CS created. Next, SQLDB. Come to SQLDB, go to connection strings, copy this and paste it here. You know, I need to replace the password, so I'm going to replace the password now. Okay, so I can say here Bangalore @123, and then I can able to copy this and I need to paste it. Okay, understood, friends? This is everybody understood this.
Yeah, Malia. Yes.
Okay, so I'll just come here, Azure keyword, click generate/import. You can say SQLDB CS SQL connection string. Just I pasted, created. Okay, now blob storage. Okay, come to blob storage. Blob storage here. Go to resource. Click on access case. So take the connection string from this blob storage and keep it there. Okay, click show keys. Copy this connection string and paste it here. So today we are storing all the connection strings. Okay, this is the blob CS. Just paste it, create it. Now we have stored all the information. Now I opened the data factory as well. Let's click on manage tab. Let's create the linked service for keyword first. Azure keyword, click continue. This is LS. So subscription is this, Azure keyword name is this, test connection, create it. Let's click a new. Yeah, we know one thing, we need to publish this. If you want to use it in other linked services, let's publish this. Let's wait. Okay, let's click new. Now click on blob storage. Yeah, let's click on see CosmosDB, MongoDB API and SQL API. You have two, right? Just click on SQL API, click continue. So this is a LS for Cosmos. LS Cosmos. So I want to use Azure keyword. So use the existing keyword connection. Secret name. What is the secret name? Cosmos. Cosmos. Yes. Cosmos. Yes. Test the connection. Connection successful. You can create it. Okay. In the same way, let's click new. Let's connect to the SQL database. Click on this. Click continue. This is LS for Azure SQLDB. I can say SQLDB. Azure SQLDB. Subscription, all these things we don't require. We just have to read it from the Azure keyword. Secret name SQL CS. Test connection. It's not a case sensitive, right? It's case insensitive, this one. That's why you can keep the small letter here, capital letter. That's work. Okay. Next, let's create a final linked service for blob storage. Blob storage. This is LS for blob. Azure blob. Azure blob. subscription is this, storage account name. Instead of doing all those things, what we will do, we will just read it from the Azure keyword. Secret name is blob cs, blob connection string, test connection. Connection successful, created. Now if you want to publish all, you can publish all these linked services, because this we need. Come back to the author tab. Let's try to start with copying data from SQL database to the CosmosDB. First, I will copy data from SQLDB to the CosmosDB, because already I have data in SQLDB. I have created a table and I inserted some record. Let's create a pipeline. Okay, this pipeline is basically going to copy data from PL underscore data for moving data from SQLDB to Cosmos. Okay, this is the first one. This is our first pipeline. Okay, let's bring the copy data activity. What is our source? CosmosDB. Okay, let's come to source. What is our source? Let's select our source. Our source is SQL database. Select SQL database, click continue. DS for Azure SQL DB. This is act as a source for us in this. This is a source to us. Right? So linked services, same linked service which we have created. Let's select the table, because we don't have multiple tables to pass one by using dataset parameters, right? Just use that table, click OK. Next, I want to load this data into CosmosDB. Click new. CosmosDB, as I mentioned, MongoDB API, SQL API. Just select SQL API, click continue. This is PS for CosmosDB as a sync. Select this. This one. Okay. Let's click OK. See, I'm not selecting here, so I just selected the Cloud Pandit DB one. This is the database I have selected. Schema validation database name should be okay. Valid database name should be provided. We have provided correct one on linked service. Let's click OK once again. In the drop down itself. Okay. One second, I think we made a small mistake. One second, let me just check. No issue with this. Okay, click cancel, click new once again. Let's select SQL API, click continue. Sync one. Linked service is this. Where is the one? Click none, click OK. Set is
Cosmos spelling.
what?
Cosmos spelling.
Cosmos?
Spelling mistake.
Okay. Spelling mistake. Okay, that's okay. Click on this. If you want to change the name, just here you can see Cosmos. Cosmos. Okay, that's okay. Okay, come here. So here we have a write behavior, two things, insert and upsert. Let's go with insert because we want to insert only. Just click debug. Now come to CosmosDB, click on Data Explorer, go to, click on this database, click on this container, click on items, you will see all these items. Copy activity is not completed. It is job is queued, got filled successfully. Okay, 1 second, come back here. So database name, please don't use numbers in database names. Okay, let's click new container. I want to create a new database. Let me just change the database name to Cloud Pandit DB. I think if we have numbers in the database name, we have an issue. Okay, let's not use the number in the database name. I am just using Cloud Pandit DB. Okay, so container name, I will just say cust. This is the new database, right? In new database, I am just using cust is my container. In this, I will say cust location is my partition key. Same thing, but I just created the new database. Now you see, refresh this, you will see the new database. Now you see new database. Okay, so I will try to load data into this database. Now just click on this, refresh once again, containers, everything should come. Yeah, container came cust. Click on items, you see you don't have any items. Okay, so I think same issue is coming. Let's come here, let's create a new data set. Okay, this is SQL API, click continue. This is DS Cosmos sync. Okay, you just created the new, right? So you just say Cosmos 1 underscore sync 1. Okay, this is the another DB you have created. Okay, that's why Cosmos 1 sync 1 I'm using. Otherwise, you can say Cosmos underscore sync 1 linked services, same linked service. Okay, because account is same, under that we have created the new database. See which database we want to go. Now I want to go with Cloud Pandit 3. We just click OK. Now this time we'll see. See this time still it is saying error, valid database name should be provided. That I have tried already, no? So previously we got error. Okay, 1 second. Database name missing. Let's click on this. Test connection. Connection is successful. Click preview data. So you don't have any data. Oh, that is the reason. Still it should be successful. Okay. Let's try to do. Let's try to use the, not this one. Let's create a new one. The CosmosDB SQL API.
You are still referring to Cosmos DB 1 earlier, Mala, right? Did you observe that?
DS underscore Cosmos underscore sync 11 is the linked service. This one, let's use this connection. Not hard coding anything to make a mistake, right? So click none and try to go without importing schema. So insert only. Okay, insert only. SQLDB 2. Okay, let's try to debug once again. We'll see whether we are getting same error again. If we are getting same error again, we need to do it in a different way. I will tell you. As it is empty, right? So there is no items in it. That's where the reason maybe. That's why we are getting error. Let's try to create a sum item manually and let's try to run it once again. Okay. It's failed again. So we'll see what is the reason for this. So valid database name should be provided. It's saying again, valid database name should be provided, but we have provided the correct database name. Still we are getting issue. Yeah, so let's come here, CosmosDB. 1 second, come to data factory. Which one I am using? The latest database, right? Click on this items. Let's create a one item manually. How to create an item manually? Click on new item. Let's create one item manually. We'll see whether this is because of empty schema. I'm just creating, okay, something like this. Okay, let's click save. Okay, now automatically system generated values will come. ID must be string. Okay, this should be a string. Click save. See, now system generated keys came, right? So underscore RID, all these things will come automatically. Now I kept it under items. So now let's try to run pipeline once again. We'll see same issues coming once again. Our issue because it's empty. Valid database name anywhere I am not entering.
Maybe any limits is there, I guess, Malaya. Name, not like
If it is the limit, then it should show there itself, right? It will fail to create there itself. But that also I thought there is a number, it is not telling. I created 2. Okay, just give me a minute. Let me just try in a different way. Okay, just give me a minute.
Malaya, I pinged you one link. So there actually in connection string, if you give the database name, this issue will get resolved, it seems.
Okay. So yeah, maybe because morning, that's what I was thinking. Morning I did not use this. Okay. So to resolve this issue, yeah, Yes, Pawan told, right? So we need to go in a different way. That is, let's change the linker service. Come back to the linker service. Click on this linker service. Okay. Just click on this linker service. Yes, it will work. So I don't want to go with connection string. Okay. So let's go with normal these things. Let's select this subscription account name, database name. I will just select here. Let's select a database. Okay. I am not reading all these details from the keyword. I'm just reading everything from the database. Just click apply. Okay, so connection will be successful. Now this time I think issue will resolve. Now come here. Source side we just selected. You see source side I selected the table called cust. Okay, come back to the pipeline. Sync side, what table I have selected, you see. Okay, so in which collection? Collection is, uncheck this, click the drop down and check. See, collection means it should be a cust. Okay, collection means it should be a cust. Okay, not a database name. Database name already we have given in the linked service. Collection is nothing but a this cust. So in this linked service, what is the database we have given? You see, we have given database called Cloud Pandit DB. Means in Cloud Pandit DB, this cust table in this cust collection data will be loaded when I run the pipeline. Okay, now this time pipeline will successful. You run it now. It's successful. Okay. Now come back to your Cosmos DB now. Go to Data Explorer. Click on this Cosmos Cloud Pandit DB. Click on this cust. So go to items, you will see all those things. See, based on the customer location as a partition, right? So that's why you will be able to see your customer location. Okay. If you click on this, you will see some records here. If you click on this, you will see some records. If you click on Chennai, you will see some record. Hyderabad record. Right, so this is the Hyderabad record. So for each item, one document created. In each document, you see system generated keys we have. System generated keys we have. Now I want to filter out these records. Now click on this SQL query editor. This is the SQL query editor. When you say select star from C means collection. Instead of C, you can put anything. You can say Cloud Pandit. It will work. You will just consider all those items under this Cloud Pandit. Now just execute query. You will see all items here. Okay, you are able to see all items or not? Yes, you are able to see all these items. Now I want to filter these items where I have a C location is Bangalore. Where I have a C location is Bangalore, right? So for that, come here and say where in this Cloud Pandit collection, C location is Bangalore. Can you give me only those records? Now execute it. See here, you see this is a Bangalore record. Okay. Now total how many records you got? You see here 1, 2, 3. You got only 3. Now I will go in a reverse way. Another way is, what else you can say? Let's say I want to go with Hyderabad. Let's execute query. See how many records? Only one record I got. We inserted only one record for Hyderabad. I think spelling mistake. It's spelling mistake I inserted. See here Hyderabad, here Hyderabad. RA. Okay, spelling mistake. That's why one record came. Okay, now when you say Hyderabad, again you will get one record. Not only based on customer location. Let's say now I don't want all these extra tags. I want only these 4 records. Then you need to use column names here. Column names, it's not exactly like a SQL, but you need to use little bit different syntax. In this collection, copy this Cloud Pandit name. In this Cloud Pandit collection, I want to read CID. In this, I want to read CNAME. In this collection, I want to read C location. In this, I want to read. Yeah, that's all right. We have only 3 columns. Let's select only C location. Okay, let's execute query. Now you will see only those 3 records, key and value. Okay, let's say now I will change this one. I'll just change the location to Bangalore. Now execute query. Now you see there is a first record. There is a like 1. See, ID 6, ID 1, and ID 5. We have total 3 records. 5, 1, and finally we have a final one 6. Total 3 records. We have all these things here. Okay, clear? So now why I am explaining this, because when I'm doing reverse way, I'm going to use a query. I don't want to select the simple cust collection. When I select it, all the system generated keys will be loaded into the table. That's why I will just file this query. Just yeah, here what I want to do, I don't filter. Remove that filter and execute query. Now you see all the records items. 1, 2, 3, 4. Okay, all these things we have. Now what I will do, yeah, this is the query, right? Copy this query. Let it be query. Come to data factory. Let's create a new pipeline. This pipeline is going to copy data in a reverse way. This is going to copy data from CosmosDB, right? Just click new. Let's create a new data set for CosmosDB. This is a CosmosDB. Click continue. This is a DS for Cosmos. This is source. This is the linker service. Yes, we have changed the linker service, right? Same linker service, but we have changed this thing. So from the cust, whatever items I have, those items I want to load. Select collection, but you see in this collection I don't want to load as is, right? So I don't want to load table. I want to load as a query. That query and just paste it here. That query is here somewhere. You just copy this query and paste it here. Now just click preview data. You'll see all the data how it is looks like. See, you have items. This is 6th item, this is 1 item, this is 4th item, 2nd item, 5th item, 3rd item. You see one item which is empty. What is the reason for that? So the reason for that is the item which we have created. That is the item which we have created. Okay. Okay. So that item is not matching with any of these. That item does not have CID, CNAME, any of these. That ID is having the ID. If you remember, I have created. Let me just show you that also. Come to items. Click on this. See, ID name equal to Cloud Pandit. I have created initially to test it, right? So that's well. If you want to delete this, you just delete this. Click OK. That particular item is deleted. Now come back to the data factory. Click preview data now. You will see data properly now. You will have all items now. See, item 6, item 1, 4, 2, 3, 5. Okay, all those things I have. All these items I want to load it into my sink. My sink is what? Azure SQLDB only. Select here. Azure SQLDB. Continue. DS as Azure SQLDB. The sink. Use this. Table name, I will just select a table. See, you don't have any table, new table, right? So do you want to load data in the same table? No. I'll just click edit. Here I will say dbo.emp. It should create a emp table. Click OK. Now you know if the table is not available, you cannot import the schema. You need to click none. Click OK. Then what else you need to do? You need to say auto create table, because table is not available. It should create automatically. Now click debug pipeline. Okay. So this pipeline name I will rename it. For now, let it run. See, this is successful. Come here. Here, let's say select a star from EMP and execute it. the table should be available because it's loaded. No, you see all the data came into this table. Clear how I am reading data from CosmosDB, how I am loading data into CosmosDB. Is this clear? Only the issue came because that linked service. Okay, in linked service we don't have a database name. So because that is, they should give if it is mandatory, but they have not given. I thought everything, whatever required, those information is available in this, but in this they have not given the database name. Okay, so that's why we are entering manually. Okay, clear, friends?
Malaya, I have one question. So, like, what is the scenario why we need to copy vice versa from Cosmos to SQLDB?
Cosmos to SQLDB. Okay, let's say you want to do further processing, or you want to make data is available to some third-party applications. Those third-party applications are not able to access data directly from Cosmos DB. In that case, maybe you want to load data into some SQL database. Okay.
Okay. And one more
Maybe
question.
all applications may not be able to connect to the Cosmos DB.
Got it.
Yeah,
Malaya. And one more thing, like while executing your, we have created one container called cust, right? Sorry, collection
yes.
called cust, right? Like
Yes.
while you're executing the query, you gave Cloud Pandit name, which is different name. How it is taking the reference to that collection?
Okay. See, that is basically what happens is in that particular query, what it indicates, it's not specific to particular container. Okay, now come back here, go to Data Explorer. Let's say click on this, click on this, click on this. Okay, now click on items. So from these items, when you just say here, click new query editor. Okay, so by default, what happens is under these items, everything is a collection. Okay, so that's why what it will consider is whatever name you have given, that name will be considered as a total records. Okay, even if you want to give cust, you can give, but it's not mandatory that you need to specify exact your collection name. This collection name can be anything. It will understand that. Okay, it will understand that this is okay. So your question is, let's say you have another container in this, you have another collection, right? Okay, let me just show you that so that you will be clear. Okay, here I'll say emp. Okay, maybe you can say e-location and create it. Okay, refresh this to see that. Yeah, I have this. Okay, now let me just put this item here. One item, I will keep it here. Okay, click new item. Here I will say id equal to maybe 1. Okay, so save this and save this. Okay, now go to query editor, select a star from cust and execute this. Okay, now we'll see. Okay, 1 second. Come here, items. Click on new query editor. Let's execute query. Okay, now you are getting one employee. Okay, now how it is identifying collection is nothing but a cust only, not a emp. 1 second, come back to your ADF now. Come here, just a preview data. I think it should consider all the items. Okay, not only this, it should consider all the items. So you see, you have already selected here collection. 1 second. Source, go to open this particular data set. So here you are saying collection, right? Collection, if you give cust, it will just select all the items from the collection. Let's say I will just select EMP now. Now come back to pipeline. Now preview data. Oh, sorry. So this query will not work for this EMP, right? So you will get empty because none of the columns are available in that EMP collection. Now, 1 second. Let me just copy this to Notepad. It will be easy for us to understand. Okay, let's say here, select what ID we have, employee ID, comma, employee name, isn't it? From this name can be anything. You just give anything. It will indicate all the items. Okay, if you want to give EMP only, that also can give. But whatever name you are giving, based on that, you need to give your cloudpandit.eid, cloudpandit.ename. Okay, let's try to find this query here. Now preview data. You are getting this or not? Pawan, you understand now?
Got it, Malaya. So here, since we are referring to the particular container name, so that's why it is pulling the data.
Yes. So this name can be anything. You can give, if it is a EMP, you can give EMP. If it is a cust, you can give cust. Okay. But what I wanted to do, I want to load this data. So I'm just going to paste this query and open this data set. Select your cust collection. Okay. Come back to pipeline. Now you understood, right? In that cust collection, I'm just selecting from all items CID, CNAME, and C location. That data I'm loading into the EMP table, right? So EMP table, I think EMP table. So this particular execution is done already, isn't it? So we are able to see all the records. With this particular execution, we already done. Okay, clear?
Yeah. So is there any way we can join these two collections, Malaya?
That's what I mentioned in the slides. Joining will not work in CosmosDB. So no
Database. Okay.
PL underscore data underscore PL underscore data underscore, you can say Cosmos to SQLDB. This is also done. Now we'll see from same Cosmos data, I will load it into a blob storage. Okay, create a new pipeline. 5 more minutes. Okay, this is PL underscore data. This should be moved from, yeah, CosmosDB to blob. It's a CosmosDB to blob. Move here. Okay, copy data. Source data I said is, you can select the existing one which you have used just now, right? Which one we have used? CosmosDB 1.1, isn't it? So here I have just fired the query, right? Same query I can fire here also. Just preview data, check it what you are getting in source side. So this is the data I'm getting. This data I want to load it into blob storage. So create a blob storage data set, blob storage as a CSV. Click continue. This you can say DS for blob as sync. Select linked service, this one. First row as header. I don't have any container, if you remember, right? Just go to overview. Come down, click on containers. You see you don't have any containers, right? So let's create a container directly from here. I will say Cosmos output. First row as header, click OK. Yeah, you don't have container, you cannot import schema, click OK. Then debug it. Come to this blob storage, click refresh. Okay, it will be a little bit quicker. Quickly it can able to load because we don't have much data, right? Within 10 seconds it should be finished. Okay, fine. So it is successful. Cosmos output folder created, container created. Inside that you'll be able to CSV file. If you click on this file, we'll have edit. Why this is .txt, we all know. In sync side we need to change the format to .csv, but format is CSV format only, data only extension. We need to change it to the .csv. So where we will change that, we know, right? Sync side here, we need to change it to the .csv so that it will be loaded as a .csv. But this is fine. We have this data. Now, what I wanted to do, let's go to Cosmos DB. I have EMP, right? In this EMP, I have items. Let me just delete this item. Just select this item, delete this item. All those customer records, I want to load it into EMP collection. So that, come here. Let's create a new pipeline. Copy data. What is our source? So source, let's create a blob data set. We don't require all these multiple data sets, but for easy understanding, I'm explaining and I'm creating multiple data sets. Okay. DS Azure blob storage source. This is basically source. Linked services this. First is header. Browse it and select the file which we have. Let's say even if you have multiple files, what you need to do? If you have a multiple files, what you will do? You just have to use the wildcard. Say I'm not selecting the file. If you have multiple files to load, then you need to select wildcard file path. Come to sync. So where you want to load this data in a CosmosDB SQL API. This is the let it be name. Linked service is this, you know. Collection is EMP. This time I want to load data into EMP. Click OK. Okay, so now this is done, right? Now just click debug. Okay, see EMP, it's a successful, meaning in the EMP here we should be able to see the items. Just to refresh this. See all items came here, customer items. Okay, the customer records loaded here. Only these three, all these are the system generated things. Okay, just click on this. Only this is our records, these are system generated keys. Okay, so this is how we can able to move data from CosmosDB to SQLDB, SQLDB to CosmosDB, whatever you want to do, you can able to do. Clear, friends? How any other
Malay,
question? Yeah. So that
Malay, is it because of dynamic schema? Cosmos DB is not supporting joins. Like in SQL, we have multiple tables and we will join, right? In Cosmos
yes,
DB,
that's
in
why.
collections, we have multiple schemas, right? We can store multiple schemas.
Correct. That's why it is not supporting. That's what I mentioned, right?
Or is
So
there an alternative for these joins in Cosmos DB?
no, joins will not support. There is no alternative.
Okay.
See, come here. I think yeah, this is the link. Suppose we are using keyword for Cosmos DB. Okay, and so this is the error somebody got, and Microsoft has provided the link, right? See, after the connection string, you need to put colon and database equal to database name. You need to mention. Okay, so this is how we need to mention. I think, yeah. Okay, if you mention this, we will not get any error. Okay, understood, friends? Clear?
Yes, Malaya.
Okay, so just give me a minute. We'll try that. Okay, because I don't want to go just like that. We'll try it whether it's working or not. I want to check it. Database equal to, we need to use here Cloud Pandit DB, right? DB1. We will try to use DB1. So this is my connection string, final connection string. This connection string I will keep it in Azure keyword. Let's try to use this linked service. Okay. Use this. Created. So this is the connection string. Go to manage. Click new. CosmosDB SQL API. Click OK. Let it be names and all. I'm not changing now. Okay, with this. Test connection first. Let's test the connection. Connection successfully created. Let's try to use this CosmosDB one linked service to maybe, yeah, let's try to load data by using new linked service this time. Okay. At least will that pipeline successful or not? I want to test it, right? So with that new linked service, we'll just try. Yeah, we need to create a, we need to select the collection, right? Let's select the collection and just select cust. See, you remember it is working. That's why it is just giving the cust. Okay. So that's how we need to add the database to our like connection string. Otherwise, it will not work. Okay. Yes, successfully. You understood? So still you can use the connection string, but you need to add the database. Okay, as the documentation suggested. I think somebody got same error. Okay. Thank you all. Thank you. Okay, that's all for today. Tomorrow we will discuss about master and child pipeline relationship. Okay, that is the one we need to discuss. Okay. Thank you all. Thank you.